Thank you. So we all know that people exchange arguments on the internet, for example, on political issues, and you might ask yourself, how similar are my own attitudes compared to those persons on the internet, or maybe even compared to political parties? But there are actually no sensible methods to determine the similarity of two argumentations. So therefore, we have developed a metric for calculating the distance between two argumentation graphs. My name is Markus Brenneis. I work at the Argumentation Research Group at the University of Düsseldorf in Germany. And I'd like to present our paper, How Much Do I Argue Like You, towards a metric on weighted argumentation graphs. Within the next 20 minutes, I'll present our work and let you know why it is useful to compare argumentations, how we can do that, and how we made sure that our comparison method actually satisfies some intuitive properties. Questions can be asked in the end, and now let's start with an example. So here we have a person which indicates their attitudes on two political positions. This person is in favor of support for organic farming and is quite sure about that. The person mentions two arguments, one supporting argument, namely environmental friendliness, and another argument against their own opinion, namely that conventional agriculture ensures a cheap basic supply with food. But the person also indicates that the latter argument is less important for them than the first argument. Then another position is mentioned, namely genetic engineering should be allowed. This person is 100% sure with this opinion and thinks that this position is actually more important than their position on support for organic farming. So which elements do we see here? First of all, we have opinions on certain statements. For example, organic farming should get more support, or it is environmentally friendly, together with a statement how sure the person is about their opinion, which we call rating later on. Then we see arguments which are formed by composing two statements. For example, organic farming should get more support because it is environmentally friendly. And each individual person can indicate that certain arguments are more important than other arguments. So for example, the environmental friendliness argument is considered more important than the cheap basic supply argument here. And last but not least, the person also can say that certain positions are more important than other positions. Now, in order to do a comparison with a different person, we have to capture all this information in a mathematical model. And of course, we use argumentation graphs for that. Our graphs are based on the issue-based information system. So we have the issue as root node here, I, which is like the overall topic of the argumentation, for example, current political issues. And then we have the statements as nodes here. So for example, O is the statement, organic farming should get more support. And E is the statement, organic farming should be environmentally friendly. So the argument, environmentally friendliness supports the organic farming thing, is represented by this edge here. Now we want to add all the information from the text above. So we add a so-called rating value here, which indicates how sure the person is about the individual statements. The rating values are from -0.5 to +0.5. So for the reasonable sure, we translate it as like 50% sure. We get a 0.25 here for this node. And for the 100% sure here, we get a +0.5 for this node here. And then we also want to capture the information which arguments are considered more important than other arguments and which positions are more important than others. And therefore we add numbers to the edges between 0 and 1. So for example, here we see that the argument of environmental friendliness is considered more important than the argument of cheap basic supply. One thing to note here is that we do not capture in the model whether an argument is attacking or not. So this is not bipolar here. Of course, if you want to consider that information too, you have to make a difference between those two edges here. But we didn't do that simply because we won't need it later on in our metric proposal. So now we have the opinions of a different person here in the example. The important thing to note is that the underlying topic, the underlying argumentation is actually the same. So this person mentions the attitudes on the same arguments and statements here. This person is against support for organic farming. So we have a negative value here with -0.5. And the person considers the position of organic farming more important for themselves than the position on genetic engineering. So this edge here has a higher value than this edge. The person doesn't mention anything on the arguments with the nodes E and C here. So those get a default value of 0 here, and later on I just won't draw them anymore. Now we come to the interesting question. Now we have a third person represented by this graph G3 here. And we want to ask the question, is that person's attitude more similar to the attitudes of person 1 or person 2? And with attitude, I mean all the opinions on statements and the strengths that the person has. We are not talking about the number of arguments used or whether counter arguments are used, whether the argumentation is consistent. We are only looking at the attitude of that person. And from an intuitive point of view, we'd say, well, okay, this person is in favor of support for more organic farming. So it should be more similar to G1, which is also supporting that position, than to G2, which is not supporting that position. So next I'll explain to you why we think that calculating the distance is actually useful, and then I'll show you how we do that. So what can this distance be used for? One possible example is a recommender system for arguments, where you want to recommend arguments which are maybe more interesting for a user because it reflects their own opinion, or maybe it does not reflect their own opinion. Actually, we do that in our software deliberate, which I show in a demo session at Comma. Then you could also imagine that you can cluster people by their attitude, or maybe find people with similar attitudes, or even political parties which share your own attitudes. So now to the question, how we calculate the distance. So let's take the graphs G1 and G3 as an example here. We basically go through every node, and then we say, okay, we take the rating value of that node, in this example 0.25, and multiply it with every rate of an edge to the way to the root node. So here 0.25 times 1/3. And then we subtract the same thing from the other graph, so minus 0.5 times 1, and then take the absolute value. Then we do it for the next node E here. We have 0.5 times 3/4 times 1/3 minus 0 times 0 times 1. And the same thing for all the other nodes. Then we add a factor alpha between 0 and 1. We use that factor to put less emphasis on deeper parts. In practical, it means if we have a higher alpha value, we have more emphasis on deeper parts. If we have a lower alpha value, we have more emphasis on higher parts of the argumentation. So more emphasis on the positions here. If you're familiar with the PageRank algorithm, we will recall that alpha value. Another purpose of alpha is that it assures that this sum actually converges in case we have any cycles in our graph. Then we multiply with 1 minus alpha, which is just for normalization, so that the whole sum is always between 0 and 1. And then we can calculate the distance. For example, with alpha equal to 0.5, we get the result 0.208 here. Then we can do the same thing for persons 2 and 3. And well, we get a greater value here. So we get the result we wanted to have, that person 3 is more similar to person 1. So those examples were here to give you an intuition how the calculation works. And I now want to introduce the exact definition. First of all, I'll introduce the special case for argumentation trees, which is a bit simpler than the general case. So here we have the normalization factor, then the sum over all statements, then alpha raised to the depth of the statement S, which assures that deeper statements have less influence on the overall sum. Then we have the rating value for the statement node multiplied with the weights of all edges leading from S to the root node I, and minus the same thing from the other tree. If we look at the more general case of argumentation graphs, we first of all introduce a matrix notation. So we have a weight matrix here for the edges. You have to read it like this. The edge from O to I has the value 1 over 3 and so on. And the node O has the value 0.25, node G value 0.5 and so on. And then in this formula, we have again the normalization factor. And then we sum over all possible path lengths to the root node. So for I equal to 1, we only consider the nodes which have a path of length 1 to the root node, which are O and G. Then we have alpha raised to the I again. Then we take the ith power of the matrix W and then consider the first column. So for the first iteration of the sum, we get this column here again, and then take the pointwise product with this vector, subtract the same thing from the other graph, and take the L1 norm, which means for the first iteration we get 1 over 3 times 0.25 minus the same thing from the other graph, plus 2 over 3 times 0.5 minus the same thing from the other graph. So you see, it actually is, in case of trees, the same thing as I've presented before. So now we ask ourselves, okay, now we got this formula, does it yield any intuitive results? And therefore we've developed a list of in total 9 properties of which we think every intuitive metric for comparing attitudes in argumentation graphs should fulfill. And here I want to present 2 of them. First of all, we said that a proportional bigger overlap is better. So what does that mean? In this example, we have a statement S supported with another statement S1. In another tree here, we have the same statement S and the same supporting statement S1, and another statement S2 on the same level. And in the third graph, we have the same as in T2, but another statement S3. And now you can see that like the relative overlap between T1 and T2 is 50%, and the relative overlap of T2 and T3 is 67%. And therefore we said that those 2 trees, T3 and T2 with a bigger relative overlap, should have a smaller distance than the first 2 trees. Then another property we propose, we say that the deviation in deeper parts should have less influence than a deviation in higher parts. So in this example, we have the statement S again, supported by another statement SA. Then in T2, we have SA again, another statement SB on the same level. And in T3, we have SA supported by SA, and then SA supported by SA1. And we think when we compare T1 with T2 and T3, that the distance to T3 should be smaller because the deviation is in a deeper part. And from an intuitive point of view, if we only have a difference in like smaller arguments for our own arguments, it shouldn't make such a big difference than having other arguments on a higher level. We are well aware that the list of proposed properties is not complete, so we could come up with more properties. We have proven in our paper that our metric proposal fulfills all those properties and have also more general formulations for them than those concrete examples I've presented here. So to conclude, we have presented a pseudometric for comparing attitudes in argumentation using argumentation graphs where we capture the importance of arguments and the how sure persons are about their statements. And we've presented a list of so-called desiderata where we propose which properties a metric comparing attitudes and argumentation should have. In future work, we are currently checking whether our desiderata actually match the intuition of untrained humans, so not of domain experts, but on laymen. First results indicate that actually the last property I've just shown isn't as intuitive as we thought on first glance. And furthermore, we want to check whether our metric actually yields good results in application context. We are actually evaluating it in a recommender system right now. And we want later on to test it in a voting advice application to calculate the distance between the attitudes of voters and political parties. So thank you for your attention, and I'm looking forward to your questions.